Hello friends, welcome to Risingpearl.com. Today is series 12 where we are discussing areas related to circles. Today's topic, friends, is solving questions on sectors and segments of a circle. This is part 2. This is webisode number 7. And the reason this is part 2, friends, is because in the webisode 6, that was a part 1, that is when we started looking at what are the different type of questions, some of the different type of questions on sectors and segments that you can expect, you can see in tests and exams, and how do you actually go and solve these questions. So friends, let's take a look at some more questions on this particular topic. So the question 1 is area of a sector of angle P in degrees, so angle P in degrees of a circle with radius R is blank. Fill in the blank. So in other words, what we have, friends, is that we can imagine a circle with center O. We can take any 2 points on the circle. Let's say they are A and B. And then the area, not the area, the angle subtended by the arc at the center, or the angle of sector is P. And the radius of the circle is the uppercase R. We have to find out the area of the sector. That is what the question is asking us to do. So we know that we have seen in our last few webisodes that area of a sector, we have a formula for this. Area of a sector is given by pi r squared divided by 360 degrees times theta, where theta is the angle subtended at the center by the arc AB in this case. So if AB is subtending the angle P, so in this particular example theta is equal to P. So what we have is pi. Now radius is uppercase R for us, so it will be pi r squared divided by 360 times P lowercase. So this is the this is the area for our sector, and this is going to be the answer to the question. So you will think this is quite a straightforward question, and I'll agree. So why don't we take a look at something which is maybe a little bit more complex than this. So this is the question number 2, and immediately we notice there are no figure or diagrams given to us. So let's read the question. To warn ships for underwater rocks, a lighthouse spreads a yellow colored light over a sector of angle 80 degrees to a distance of 16.5 kilometers. Find the area of the sea over which the ships are warned and use pi equals 3.14. So first of all, friends, let's do one thing. Let's draw the lighthouse. And here you can see I have got a very robust, dramatic picture of a lighthouse. Now imagine this is the lighthouse. This is the very top of the lighthouse, and this is actually the lighthouse. A fancy lighthouse which is on this is the base of the lighthouse, and this is the ocean or the sea water. So here we have the sea, and there are some rocks over here, right? And then the purpose of the lighthouse is to make sure that the ship, let's draw a ship over here. There is a ship which is sailing by. Let's say this ship is approaching the shores over here. The lighthouse is having this yellow colored light on the sea, warning the ships so that they can see these rocks. That is the whole purpose. Now friends, one thing is that I have drawn a very elaborate diagram here. I do not absolutely expect you to draw anything like this. There is no need for you to draw anything like this, while you're attempting to answer this question. Not in your homework, classwork, and certainly not in the test. But the idea that why we draw something like this, as you have seen me over over months and years, is that we want to make sure that you get the concept very clearly understood in your mind. So sometimes we use elaborate drawings or animations, so on and so forth. It is just to make sure that it helps explain the concept. Now imagine, so this lighthouse is basically spreading this at a certain angle. So it is going from one end to the other, spreading the yellow light. So if somehow we can get into a helicopter or any plane and go and sit right on top of the lighthouse, if you watch it from the top, how will this look like? So this is how it will look like. If this is the top of the lighthouse, right? Top of the lighthouse, then what we notice is that this is how far the light ray is being sent from the lighthouse to how far in the sea. This is 16.5 kilometers. That is how far the ray of light is going into the seawater, right? And then it is swinging at an angle. So that is, it is actually going from one side to another side at an angle of 80 degrees. That is given to us, angle of 80 degrees. From one end to the other end at an angle of 80 degrees, it is going back and forth and back and forth. And so the amount of area on which the yellow light is spread is this. So from one end to the other end, if it swings once, it covers this area which is highlighted in yellow. And as you can imagine, friends, at this point, it is nothing but, this is simply area of a sector. So to find out the area of C, we simply have to find out area of a sector, and this is the center, and this distance, how far the yellow colored light is traveling, which is 16.5. This is simply the radius. So now, friends, we know that area of a sector is simply pi r square by 360 degrees times theta, or in this case it will be pi r is given as 16.5 square divided by 360 times 80 degrees. Now we can simply solve it by putting in the values in here, and for pi we have been advised to take 3.14. So I will not be doing the computation for you, but I mean, if you just put like 3.14 over here, and you have to find out 16.5 whole square divided by 360 times 80, you will find this much kilometer square is the amount of area on which the ships are warned. Now if you just take a moment, friends, and compare this question with the last question. In the last question, the sector was given, angle was 80 degrees, and radius was given, and we were simply asked to find out the area of the sector. We applied the formula and then we got the area of the sector so easily. But in this question, instead of giving us any figure, the entire question took a real life example. We were not provided with any diagram, but this question is exactly the same as last question in terms of the essence of it. So we just, by reading the question carefully and making sure we actually have the right diagram to represent the question, if we do this correctly, if we read the question correctly, and if we appropriately draw the diagram correctly, then we can solve any question. And in this question, this should have given us the clue that there is a sector involved of an angle at a distance, and find the area of the sea. So by comparing what is given in the question with the way we understand the question, we can simply solve such problems. So now, friends, let's take a look at one more question. So here we have this question number 3. A round table cover has 5 equal designs as shown in the figure. So this is a round table cover, and there are 5 equal designs. So we have some sort of a pentagon, which is a pentagon means 5 sides, and then there is a design between the edge, each of the edge of the pentagon and the outer part of the circle, like as shown. This is the design which is given. Now if the radius of the cover is 28 centimeters, so from the center, if we randomly pick any point on the circle and simply join the center with it, that will be the R, and the radius is given to be 28 centimeter. Find the cost of making the designs at X per centimeter square. And some values are given. So how do we approach a question like this? So first things first, friends, I think first you have to recognize that the question is talking about a cost. Now normally whenever we actually handle these kind of questions, we see that they're asking either about area of a circle, area of a sector, or area of a segment. But here the final answer is it's a cost. But cost of what? Cost of making the designs. So these designs need to be made, and it costs certain amount. It costs X amount per centimeter square. And we have been asked, find out the total cost of making the design. It means that we have to first find out the area of these designs, right? And only then, so let's say the area of the designs is Y centimeter square. So if the total amount of design or the area for the design is Y centimeter square, and if 1 centimeter square costs X, so the total cost then will be X times Y. This will be our final answer. So we have to actually find out the value of Y, which is how much is the area of these designs. So now that we have understood that, so we can think of this as, so this can be thought about as area of the entire round table cover. So if I were to draw a circle which is the same circle as this and find out that total area is highlighted in blue, and then simply take away the area of the pentagon, right? So the entire circle area of the circle minus the pentagon, then we are left with just the area of the design. So in other words, the area of the design is equal to area of the circle minus area of the pentagon. And why am I saying it is a pentagon? Obviously because it has 5 equal designs, right? So it is a pentagon. If this were 6 equal designs, it would have been a hexagon. Now this area will be the Y. So this will give us area of the design. And once we find this out, we are going to simply multiply this. With X to find out the cost. So now friends, let's clean this up and let's look into it. So now area of the circle, clearly, which is the area of the round table cover. So this area is given by pi r square, or equal to pi, we will write this as 22 by 7, and then 28 times 28, because r is given as 28 centimeter square. So 7 4s are 28. So 22 times 4 is 88 times 28. This much centimeter square. Now at this point, friends, this is the area of the circle. We are not going to go ahead and compute this. Why? Because it is highly likely that as we continue through step by step towards a solution, we may be able to take some common factors which may eventually cancel out. So then our numbers may become smaller and smaller, which are much easier to compute and calculate. So unless and until we absolutely need to perform these calculations, we are just going to basically push it out and push it out and push it out. So now let's find out how do we calculate the area of the pentagon. Now this is going to be comparatively much more harder. So now let's do one thing. So let's draw the pentagon a little bit in a bigger way so that we can clearly see it. Now if you look at, so first thing is that the area of the pentagon, which is highlighted in blue, what is the area of a pentagon? Area of any polygon, friends, if you will recall, this is equal to half times perimeter of the polygon times A, or sometimes it is also called the apothem, which basically means that if you were to draw a perpendicular from the center to any one of the sides, then this length, the length of the perpendicular distance between that, or in other words, if you were to draw up a perpendicular from here on any of the side, this length will be A. So area of any polygon, whether it is a quadrilateral or it is quadrilateral polygon will be a square, right? Or if it is a pentagon or a hexagon or heptagon, so on and so forth, it will be always equal to half the perimeter times this perpendicular distance, right? So now this is the area of the entire pentagon. But so we need to find out the perimeter. Perimeter is if each of these sides, if let's say each of these sides is B centimeter. If this is B, 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 so then the perimeter will be equal to 5 times B. So we need to find out each of these lengths. We need to find out one length, right? And also we need to find out this value, the perpendicular distance. So the first thing, friends, that you should recall is that whenever you have a regular pentagon, the pentagon subtends equal angle at the center. And we can actually prove it, but this is something that you must know, right? By simply comparing this triangle and this triangle, you will notice that this is equal to this. They are the radius in this case, right? And this is a common side, and these are sides of pentagon. So they should be equal. So these two triangles are congruent by SSS congruence rule. So these two angles should be equal. Now, if there are 5 sides, 1, 2, 3, 4, 5, there are 5 angles at the center. So each of the angle then, if I call each of these angle theta, 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 so there will be 5 thetas which will be equal to 360 degrees. Because if we take all of them together, that is 360 degrees, or theta equals to 360 divided by 5, or which will be 5 sevens are 35 times 2, 72 degrees. That means this angle is 72 degrees. Now if this angle is 72 degrees, one other thing to keep in mind is that if you take a look at triangle, let's name this maybe A, B. If you look at triangle AOB, then this angle plus this angle, if this angle, or in other words, angle OAB should be equal to angle OBA. So why is that? These two angles should be equal because this is radius and this is radius. So this is isosceles triangle. So these two angles are equal, sides are equal. So these two angles are equal. Now if this angle is given as 72 degrees, so how much is this angle? So then we can say angle OAB will be equal to sum total. If this is, let's call this as maybe, let's say this value is, let's take a letter S. So this is S, this is S. S plus 72 equals 180 degrees. So each of these angle will be equal to 180 minus 72 divided by 2. So if you solve it, you will get 180 minus 72 divided by 2. This will be 54 degrees. That means each of these angles is 54 degrees. We have still not found out what is the length of each side, and we still have not found out this perpendicular distance, right? Actually this angle should not be theta. Theta should be this angle. That is, all the sides subtend equal angle, right? This is just a perpendicular. Alright, now I think we got a lot of stuff going on. Let's just clean this up. So what we are going to do, friends, is that now we are going to drop a perpendicular from the center to one of the sides. Let's just name this. So we call this as A, this is B, let's say this is C, and let's say this is X, and this is 90 degrees by construction. Now we just saw this angle is 54 degrees. This angle is 54 degrees. And this is R. So if you look at triangle, AOX, now this is a right triangle, right? because angle X or OXA is 90 degrees. Now, and we know this angle. So at this point, friends, we can apply we can apply trigonometry, because we know that if we know one of the angles and one of the sides, then using trigonometric ratios, we can find out all the remaining sides. So by simply doing sine 54 degrees in triangle AOX, we know that sine of any angle is opposite side OX divided by the hypotenuse, which is R, or the value of R is given as 28. Now the value of sine is given to us, it is 0.81. We are going to use that, and from here we find out OX is equal to 28 times 0.81. This much centimeter. Now what is OX? OX is this length, which is A for our area. Now also by comparing cos 54 degrees, we can see that in this triangle AOX, cos 54 degrees will be AX, which is the adjacent side, divided by the hypotenuse, which is 28. But cos 54 is given as 0.59. So from here we can find out AX is equal to 28 times 0.59. This much centimeter. So now we know AX, but X is a midpoint of AB. Why? Because if you simply compare these two triangles, you can prove these two triangles are congruent, and so X is the midpoint. By using RHS, you can prove these two triangles are congruent, this and this, and so X is the midpoint. So AB is equal to 2 times AX. So AX, or 2 times 28.59. So now this will give us AB. Now AB is the measure of one of the sides of a pentagon. So the area of the pentagon will be equal to half times perimeter, which is this length AB times 5. It is X. It is not X. It is this length, this length, this length, this length, this length. So 5 times AB, which is this value. 2 times 28 times 0.59. Now this is half perimeter times the perpendicular distance A, which is given by this. So it is this times 28 times 0.81. So this entire thing, friends, is the area of the regular pentagon. Now, so we have found out the area of the circle, we have found out the area of the pentagon. Now quite simply what we can say is that, let's say the area of the pentagon that we just saw was Q. Now area of the circle we saw was 88, I think it was 88 times 28, and this is Q, and Q will have a value. So when you solve it, you will get a value. So the area of the design, is equal to this area minus Q, which we know the value of. So the cost of the design, simply is this entire thing times X. Because to do 1 centimeter square, if it costs us X amount, then to cover this much centimeter square, it will cost this times X. So friends, clearly this is by far the most, I think, not the complicated, but more difficult. Maybe it is more complex. It has many steps, right? So, and especially when we had to solve area of a pentagon or any polygon, which has 5 or more sides. It is a little bit more involved. But again, by following our step-by-step manner, we have found out how we can solve these questions. Clearly, it is more difficult, it is more complex, and it took us longer. But we can, if you understand the question, if we follow the steps one by one, we are going to be able to solve all of these questions.